So we've looked at the parts of a solution, and we've also looked at curves that can show us how much solute can dissolve in a solvent and how that changes when the solvent changes temperature. Another thing we can look at is the strength of a solution. And this kind of goes back to the vocab that we mentioned, concentrated versus diluted. If you remember, a diluted solution has more solvent than solute. So in this case, I have, and I'm being very elementary here, but I have just 4 particles of solute dissolved, let's fill this up, I guess, dissolved, he left the water, in my solvent. So that would be my diluted solution. That's review. And then if we had a whole bunch of particles in this guy, this would be my, what word describes him? What? Don't whisper it. What is it? Oh, not saturated, though he probably certainly is with that much. Concentrated. All right, remember, if there's a bunch of solute compared to the solvent, it's concentrated. There's another way to look at this. Rather than generalizing and saying, as you said, well, this looks saturated or maybe supersaturated and this looks unsaturated, or simply saying, well, this is dilute and this is concentrated, we could take the time and count the dots and know exactly how much stuff is in there and assign a numerical value to that. Molarity is the strength of a solution. The more concentrated it is, the higher the molarity will be, because the molarity is the mathematical, the quantitative look at how much solute you've dissolved in the solvent. Molarity plays a big part in my life when I'm preparing things for you, because I know the molarity at which things are too strong to the point where they will hurt you. For example, our acids come in what's called 18 molar. That's burned through your skin strong. A molarity of 18 means that the amount of particles dissolved in the solvent is ridiculous. So what do I do before I prepare a solution for you? Well, what you may have noticed in labs before, all right, you probably just looked past it because I've never actually had you look at it, but by law I have to label it this way. But on the strip of tape that's on something like HCl, that's hydrochloric acid, you've seen expressions that look like this. And this means 2 molar hydrochloric acid. What I've done is I've taken the 18 molar that was stupid dangerous and diluted it to 2 molar. This number describing the amount of particles dissolved. This is much weaker of a solution and will do a lot less damage. Your job today is to be able to calculate this number. I can give you situations and you can run through a very simple equation. Sometimes you have to go through 2 steps to figure out the molarity, the strength of a solution. I don't have an eraser. This is our first problem. You can pause the video and write it down. On your cheat sheet, you'll see the equation to find molarity. It's an equation that I'll give you on the test. You don't have to memorize it. It says to find molarity, which is the capital M, you need to divide the moles of solute that you put in. All right, remember moles is our counting unit. So how much of the solute you put in, and we'll divide that by the amount of solvent, which would be measured in liters. So here's our simple equation. Now, some problems are very easy. You'll notice that this first example we're about to do is an easy problem, and the new online assignment that is assigned, I just haven't written it yet, will have a couple of these easy ones. So let's just see how a plug and chug can happen. Take a look at this problem that you wrote down. For word problems, I always like to pull out the numbers with the units, but it says there's 12 moles of sodium oxide in 145 liters of solution. Find molarity. So I'm going to show my work. 12 moles is one of the expressions I see. write down with me, just below where you wrote the word problem. All right, 144 liters if you compare these units to this, all right, it wants to know how strong is it? What's the molarity if that's the situation? All right. So molarity equals moles, which is 12, divided by liters, which is 144. Find an answer. What do you get? Yeah, I get 0.08. 0.08 molar. All right. The units for molarity is a capital M, and you pronounce it molar. Do you think this is a strong or weak solution? It's weak because the number's so little. All right. There's some solutions that, depending on what it is, I won't be able to ask you that question. But in general, if it's a small number, it's weak. If it's a bigger number, it's large. Anything over 3 molar is usually something, depending on the solution, that might be entering a more dangerous zone. But we're done. We've solved this problem. So again, some of them really are that easy. I want to point out that this equation can be rewritten a couple other ways for different things to be missing. So I'll write those down for you in case you're not good at the algebra to move the expressions around. But moles equals molarity times liters. And liters equals moles divided by molarity. Just in case you run into a problem that asks for something different, I'm happy to help you out there. Here's the problem. In lab, when we're adding salt to water, and we have an amount of salt there, and we're going to want to know what molarity we're about to create, we usually don't look at the salt and calculate how many moles of it that we have. We usually calculate how many grams of it that we have, because if you have a balance there, you can put the salt on a balance, boom, grams. Finding moles takes more steps than that. And that's why the other type of problem exists. If the word grams is anywhere in a molarity problem, then there's 2 steps you'll have to do instead of 1. Now, when I say 1, this equation, you're going to use this in a molarity equation, in a molarity problem, no matter what. You've got to use the molarity equation. So that's happening in every molarity problem. It's just if grams is a part of the problem, then you're also going to have to use one of these grids that you see on your cheat sheet. But there's 2 different ways that grams can be used in a problem. Grams can either be a given value, in which case one of those cheat sheet routes applies, or grams will be an unknown value. So let's check out this problem, and I'll show you the correct way to think through a molarity problem with grams. I'm going to pull out the numbers. The first number I see is 0.300 liters. All right, always pull the units with them. The next number I see is 4.5 molar. And then what's it asking for? It says how many grams. All right, so there's our setup. So here's what my brain does. It says, grams. I need to use this at some point, but I'm also going to have to do another step. Now, go to your cheat sheet. You'll see I've boxed off the 2 scenarios for you. The top one talks about if grams is a given value. Is grams a given value in this problem? No. So let's go to the next box then. The next box says if grams is an unknown value. And then the cheat sheet grabs you by your hand and walks you through exactly what to do. So you just have to be able to read. Here we go. If grams is the unknown value, reading off the cheat sheet. First, use the molarity equation to find moles. Okay, let's do that. It says first we're going to use the molarity equation to find moles. How do you find moles? Molarity times liters. Do you see why these other versions are helpful? You could do it from this if you plug your stuff in, but if you know all three versions of the formula, it makes it easy. So, to find moles, it's molarity, 4.5, times liters, 0.3. Calculate that answer. What'd you get? Okay, 1.35. Now we're not done. 1.35 moles. Now go back to the cheat sheet. Remember, it's just telling us exactly what to do. All right, we use the equation to find moles. Then enter the mole value that you get into the grid that it shows you. So let's check out this grid that it builds for us. All right. Copying down carefully, it looks like it's moles, moles, and grams. You just have to be able to copy. What number does your cheat sheet says goes right here? The answer from the equation, which was what? 1.35. What number does it say goes right here? A 1, copying off your cheat sheet. And then the part everybody hates, what does it say goes right here? Periodic table. I had you get one out at the beginning of this lecture. Look at the problem. It tells you where to go look on the periodic table. What compound? Sodium chloride. All right, so we just need the molar mass of 1 Na and 1 Cl. All right, 1 sodium has a mass of 22.99. 1 chlorine has a mass of 35.453. All right. So if we add those together, all right, add them together. We've done this a million times. What's the molar mass of NaCl? Everybody okay so far? .443 is the PT value. And we all know how the grid works, right? Multiply across the top and divide by the bottom. 1.35 times 58.443 divided by 1. You can do it all as one function, and you're going to get the answer. If you round correctly, you'll get 78.90. Now, you might never have to do it, but this is really good information. If you're sitting there with a beaker that's got 0.3 liters in it of water, and you want to make a 4.5 molar solution of sodium chloride, salt water, you have to add exactly that many grams of it, of salt. if you measure out about 79 grams of salt and put it in there and mix it all together, it'll be 4.5 molar. Let's do another one. The biggest problem you'll have on computer days is y'all don't do the process the way that I show you right here. Pull out the numbers first. 151 grams is the first thing I see. All right, so that's how much stuff we're going to be putting in, is 151 grams of solute. It also tells me how much solvent I'm putting it in, 26.0 liters. What does this problem want us to find? It says, what is the molarity? Remember, molarity is capital M. We have a siren go off that says, hey, grams, look, there's grams. We're going to have to do something extra. So we go to your cheat sheet, and we'll figure out which of the boxes comes into play. The first box says, if grams is given. Is grams a given value? This time it is. So we're going to do things slightly differently. It's actually the exact same two steps, just in the opposite order. But the cheat sheet will tell you. If grams is given, first, convert grams to moles using that grid. First, we're going to use a grid. So I'm going to copy that grid exactly as my cheat sheet shows it. All right, there's the G's and MOLs. Please stop me if you need to. All right, so let's check out the grid. The top left square here says the given number. What's the given number for grams? 151. What's that square down there say? Boo. Periodic table. All right. If you look at our problem, you'll see that we're dealing with potassium phosphide. So we've got potassium with a PT mass of 39.098. But there are 3 of him, right? We've got phosphorus with a mass of 30.974. And there's only 1 of him. So let's find out what 3Ks is. All right. Potassium 3 times is 39.098 times tree. I get 117.294. And then, of course, we want to add these two guys together then to get the total molar mass. I get 148.268. Any questions so far? So that was the PT of K3P, 148.268. All right. And what number goes here? A 1. Based off your cheat sheet. Multiply across the top, divide by the bottom. 151 times 1 divided by 148 times 0.268, sorry. Somebody give me an answer for the grid. 1.02, perfect. 1.02 moles is what that actually gives us. And if you look at your cheat sheet, it says first convert the grams to moles using this grid, and it hands you a grid that will do that. But we're not done. We're looking for molarity, which is how strong the solution is, not the amount of moles dissolved in it. So let's go back to our cheat sheet. It's going to tell us to do a second step. We already did that grid. Then use the value for moles in the molarity equation. All right, so now we're good. We've noticed how in this problem we haven't used one of our equations yet that we always will have to use. We're solving for molarity, which is moles 1.02 divided by liters 26. .02 divided by 26. And we have another weak solution, which is good. That means it's safer to handle if it's weak. I'm going to have you do one by yourself in a second, but listen to the summary again so you're not the student that forgets all of this tomorrow. All right? 3 different ways the problem can be given. Grams might not be given at all, in which case you'll only have to use the molarity equation and be done with it. It'll be very quick, and I will ask you questions that are that easy. Grams will be a given value. If grams is a given value, you're going to do a grid first, and then use the molarity equation. Or grams will be the unknown, in which case you're going to do these 2 processes, but they're flipped. You're going to use a molarity equation first, and then use a slightly different grid. Solve. Let me know if I can help you. Let's figure it out systematically. I'm going to pull the numbers out of the problem as always. 295 grams, 10.2 molar. What is the volume? What are the units of volume? Liters. So make sure that hopefully you knew that. All right. By now you should. All right, so let's know how many liters, because volume is liters. All right, I have the siren go off, because I see a G. So I know I need to use one of my extra guys here. It looks like grams is the given, so it's going to be this first square. If grams is given, first use a grid, then use the equation. So there's the grid. All right, copied right off of my cheat sheet. Given grams is 295. This is the number 1. PT grams, my compound in this problem is iodine. Iodine's diatomic, so we exist like that. So we need iodine, which is 126.904, twice. You get 253.808. $253.808 is the PT of I2. 295 times 1 is 295, divided by 253.808, I get 1.16. I've done the first part of what the cheat sheet says to do. Then, use the mole that you got in the equation to solve. This problem has us finding liters. To find liters, it's moles divided by molarity. My moles is 1.16 divided by molarity of 10.2. And we can find out how much water all of this was dissolved in. I get 0.11 liters.